This is an example of quadratic model building, or an application of a quadratic model. So the price being dollars and the quantity x sold of certain product is given by that equation, and price can only be between 0 and $20, including $20, and as you can see, it can't take on the value 0. Now, the revenue function is nothing but price times the number of units sold. So in our case, the price function is given, and we just have to multiply it by x. So x is minus 5 times price plus 100, which means the price function in terms of x would be x minus 100 equals minus 5p, divided by minus 5. P would be minus 1 over 5 times x, minus 100 over minus 5, which would mean p of x would be minus x over 5 plus 20. So that is our price function. So if I multiply the price function by x, I would get the revenue function. So minus x squared over 5 plus 20 times x. Now we could find the revenue when 15 units are sold by plugging in 15, so minus 15 squared over 5 plus 20 times 15, which should be negative 225 over 5 plus 300. So negative 225 over 5 would be 45, so we have negative 45 plus 300, which should be $255. Now, we would like to find the quantity that maximizes the revenue. Now, what is the maximum revenue? Now, the revenue function, if you observe carefully, is minus x squared over 5 plus 20 times x. That is a quadratic function that is open downward, because the coefficient a is negative 1 over 5. The coefficient b is 20 and c is 0. So the vertex is going to give us the maximum revenue, and the location of the maximum revenue. So the maximum revenue would be the y value. The location of the maximum revenue would be the x value. So the formula for the vertex is minus b over 2a, that is the x value. So we have minus 20 over 2 times minus 1 over 5. The minuses would get cancelled, so you'd have 20 times 5 over 2, which would give us 50. Now f of h would give us the y value, so f of 50 would be negative 50 squared. I'm plugging it back in our original function. Here f and the revenue function are one and the same, plus 20 times 50. 50 squared is 2,500, so you have negative 2,500 over 5 plus 8,000, which should be 1,000 minus 500. We'll get $500. So according to this problem, the maximum revenue is $500, and it occurs at x is equal to 50, which should mean 50 units should be sold to achieve maximum revenue. Now, what price should the company charge to maximize revenue? And what price should the company charge to earn at least $480 in revenue? So maximum revenue happens at x is equal to 50. So since maximum revenue happens at x is equal to 50, and our price function was x equals 5p, negative 5p plus 100, we just have to plug in 50. So if we plug in 50 for x, we have minus 5 times p plus 100. So 50 minus 100 would be negative 5p. Negative 50 would be negative 5p. This would mean p is 10. So to maximize revenue, the price must be set at $10. Now we've got to determine the price so that the revenue is at least $480, which would actually mean that we have the price function as minus 1 over 5 plus 20, the revenue function as minus 1 over 5 x squared plus 20x, because it is x times price function. So we would like the revenue function to be greater than or equal to 40, which would mean negative 1 over 5 x squared plus 20x must be greater than or equal to 480. So 1 over 5 x squared plus 20x minus 480 has to be greater than or equal to 0. Multiply by negative 1 over 5 on both sides, or multiply by negative 5 on both sides. You'll have x squared times or x squared minus 100x plus 480 times 5 less than or equal to 0, because the sign would flip. So you'd have x squared minus 100x plus 2400 less than or equal to 0. That's a quadratic function, and you could use the quadratic formula to find the places where it would equal to 0. So we have minus of minus 100 plus or minus square root of b squared minus 4 times a times c over 2 times a, which is 1. So we would get 100 plus or minus square root of 100 square minus 2400 times 4, which is 9600. That would give us 400 divided by 2. So we have 100 plus or minus 20 over 2, so which would give us 120 over 2 and 80 over 2. So the two places where x would become 0 would be, or the quadratic equation would become 0 would be at $60, 60 units and 40 units. So x must be, so if we set the number of units between 40 and 60, then that would imply the revenue function would be at least greater than or equal to 80. So if we set the number of units between 40 and 60, the revenue function would be at least for $480. So we've got to find the price range for the quantities that we have. So we take the values here and plug it back in the price function. So when we plug in 40, we have 40 plus 20, so you'd have minus 8 plus 20, which is 12. And when you plug in 60, you get minus 1 over 5 times 60 plus 20, which is minus 12 plus 20, which is $8. So if the price is between $8 and $12, then that would imply the revenue would be at least $480. So in order to determine revenue is at least $480, first we've got to find the places where x would be equal to 0, so that we will determine the point, the number of units to be sold, where the number of units to be sold such that the revenue would be greater than or equal to 480. And then we take the values, plug it back in the price function, and that will give us the price range, and the price range must be between $8 and $12 in order to get a revenue of at least $480. This is another problem on quadratic modeling, and what we have is a quadratic function right over there, h of x, and it models the height of a projectile above water with respect to the place where it was fired from. So a projectile is fired from a cliff 200 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 50 feet per second. So that 200 is the initial height, the 200 feet given in the problem. So x is the horizontal distance of the projectile from the face of the cliff. So at what horizontal distance from the face of the cliff is the height of the projectile a maximum? So we want to know the height, the position x where this height is maximum. So this is a quadratic function, so we could write it as negative 32, or 32 divided by 50 squared is 2,500, and we will get negative 0.0128 x squared plus x plus 200. So A is negative 0.0128, B is 1, and C is 200. Now clearly, since A is negative, the parabola is open downward, somewhere, which means that there is a maximum height that we can attain. So our objective is to find that maximum height, so that maximum height corresponds to the vertex. So horizontal distance, where the height is maximum, is obtained using the vertex. The vertex is h, k. The x value would correspond to the horizontal distance, and y value would correspond to the maximum height. So we know the formula for h, which is minus b over 2a. So we have minus minus 1 over 2 times minus 0.0128, which is 39.0625, and that is nothing but the x value. Don't confuse this h with the h of x. The h is the x coordinate in the vertex. K is f of h. Now f is nothing but our height function. So we're going to plug in 39.0625 in our given height function. So we will have minus 0.0128 times 39.0625 square plus 39.0625 plus 200, and we get 219.53125. So this would be the maximum height attained, and this would be the horizontal distance from the cliff where max height occurs. So that answers part A and B. So at what horizontal distance from the face of the cliff will the projectile strike the water? Now you've got to recall the cliff is at a height of 200. So that height is 200, and the projectile is going to go up and it's going to hit water. In other words, we want to know where it's going to become zero, the quadratic function. So we could use the quadratic formula and set the height function equal to 0, because the height of the cliff is 200, and find the solution x, which is the horizontal distance from the cliff where it's going to hit water. And we can use the quadratic formula, which is minus b plus or minus square root of b squared minus 4 times a times c minus divided by 2 times minus 0.0128. So we'll have minus 1 plus or minus square root of 1 plus 800 times 0.0128 over minus 0.0652. So we could find this square root first. 1 plus 800 times 0.0128, and that's 3.352. So we have minus 1 plus or minus 3.352 over minus 0.0256. So we have two solutions: minus 1 minus 3.352 divided by minus 0.0256. That gives us 170. And if we use the other case, which is minus 1 plus 3.352 divided by minus 0.0256, we'll end up getting negative 91.875. But we know the horizontal distance cannot be negative, so the only feasible solution would be x is equal to 170. So at the horizontal distance of x is equal to 170, the projectile would hit water. So we can graph this function between 0 and 200. So the x values would be from 0 up to 200, and the y values can range somewhere between 0 and, since the maximum height is 219.53, let's set it at 225. And we go to y equals negative 0.0128 x squared plus x plus 200, and we graph. And you can see it happens very close, the maximum height happens very close, and that's the place where it becomes 0. Now we could verify these solutions. We could find the maximum by pressing second trace, select number 4. I'd like to find a left bound of the maximum, so I'll set it over there. Then I'm going to give it a right bound, set it over there, and I will hit guess, and that's going to give me the maximum location, and you can see the maximum is 39.0625. That's exactly what we had, the horizontal distance, and the maximum height is 219.53125, and that is exactly what we had. It works perfectly. Now we could also verify this answer of 170, because that's where it crosses 0. So second trace and hit 2. Left bound is right over there, and right bound is somewhere way below. That number. So hit enter and give it guess, and it says y is 0 when x is 170.023. For some reason we got exactly 170, so we were able to verify that as well. When the height of the projectile is 100 feet above water, how far is it from the cliff? So the height is given. Now we are trying to find the distance from the cliff. So our height function is minus 0.0128 x squared plus x plus 200. The height is 100. So 100 would equal minus 0.0128 x squared plus x plus 200. So 0 would be equal to 0.0128 x squared plus x plus 100. Again, we could use the quadratic formula, or we could take a graphical approach. Let's use the quadratic formula first, which is minus b plus or minus b squared minus 4 times a times c over 2a, 2 times minus 0.0128. So we'll get minus 1 plus or minus square root of 1 plus 5.12 over minus 0.0256. It's clear here, and have minus 1 plus square root of 6.12 divided by negative 0.0256. Clearly that can't be an answer because we get a negative solution. -1 minus square root of 6.12 divided by negative 0.0256, and that would give us 135.69. 7, approximately 135.7. So that is the horizontal distance, where the height is 100 feet above the water. The horizontal distance from the cliff, where horizontal distance from the cliff where projectile is 100 feet above water. We could verify this by going back to our original function here, just making a slight change. 200 becomes 100 in this problem. We could hit graph again, and we're looking for the place where the projectile is 100 feet above water. Again, in this case we are setting equal to 0, so we're looking for the 0. Second trace, number 2, left bound, keep going, cross the 0 and head to the right and hit guess, and you can see the 0 happens at 135.69779. So this x, the distance 135.7, results in 0 for that equation. 0 for that equation actually means the height above water is 100 feet.